Hello everyone. So today we are going to talk about OOPS fundamentals for Java. So basically there are four pillars of OOPS, which is polymorphism, encapsulation, inheritance and abstraction, which we will be covering in this video, all these four topics. So basically what exactly is OOPS? So OOPS is an object oriented programming system where which we focus on the word object. So everything we annotate here is object. So what exactly the object is? So object is a basic unit which represents the real world entities. For example, a car, a bike, a flower, a book. The object can be physical as well as logical. So for example, physical object is like a car or a bike, and the logical object is like a banking system. So how to identify the object? So there are three properties associated with every object, which is its state, its behavior and its identity. So now let's say we have an object which is a pen. So what will be its state? Its state will be its color, which is like a white color. Then we will be having a behavior. So a pen can write or it cannot draw. So that is its behavior. And then identity is something how to identify it uniquely. So its brand could be the uh, identity. So let's say we have a Reynolds brand. So a state represents the data of that object, like what exactly that pen here is going to do. So in the behavior we can say a pen can write, or if we have let's say a logical object that may be like a banking system, there we can withdraw and deposit the money. And in the identity, it is used by JVM for internal identification of every particular object. So So to create an object, a class is required. So what exactly is a class? A class is nothing, just a group of objects which has a common kind of properties. It has a logical identity and it cannot be physical. So every class has two kind of things in it. So one is like fields and another is method. So for example here, a class is bicycle, and the field is like gear, we are saying private integer gear, we are giving the value, and behavior is what this exactly bicycle can do. It can like do the brake thing. So whenever this function would be called, the brake would be applied, whatever the particular things would be written in this side inside this particular method. So every those functions would be done inside this particular method. So here the bicycle, when we are calling the braking method, the bicycle is going to press the brake over there. So now what are the different ways to create an object in the Java? So there are many ways to create an object. Majorly they are like we can create by a new keyword, by a new instance method, by a clone method, by deserialization, and by factory method, and so on. So let's say now we have a first pillar of our OOPS, which is called data abstraction. Data abstraction is nothing, just the process of hiding the complex details or the internal details of an application from the outer world and showing just the essential information and hiding the unnecessary details. So let's say for example we have a car and we have a key. So when we put the key, we just start the car, but how exactly the car starts, we don't know that. That is the internal details which has been hidden from us. So this is like the example of data abstraction. Another example we can say is we have a system.out.println, and whatever we write inside this line. So we just write this sysout line. What exactly is the internal details, we don't know. So this is the behind the code of that println method. So all those things, these are hidden, and we can just use the println method and it provides us the all functionality for that. So how can we implement the abstraction? So there are two ways. One is like abstract keyword we can use for like abstract classes and abstract methods, and second is we can use it by interface implementation. So these are the two major ways of implementing the abstraction, and now we can talk about the advantages. So first main advantage is like we can get the security, because all the details are hidden from the user. What are the internal details of that method, that has been hidden from the user. And second is the enhancement. So since only the top layer is accessible to the user, we can change the backend code and user won't be able to see the changes done behind the scenes. So for example, we have a front end and we have a back end. So let's say our front end is like set already to React, and behind the scenes earlier we were into Node.js, and now we want to change our backend code from the Node.js to Java or Python. We can do that behind the scenes. The user will be just getting the UI system as it is to them. They won't know how the details has been changed from one language to different. They just get the details done to them, like they will get the details how this particular, they will, for them it will be like there are no changes done to them, but behind the scenes there are many changes which has been done. So that is one of the primary example and the good example, I would say, for the data abstraction. So now the second pillar of the OOPS comes into the picture, which is called data encapsulation. So data encapsulation is the process of wrapping up the code and data together into a single unit. So class would contain data members and variables into a single unit, and we can encapsulate them by using the methods public and private. Why do we need encapsulation? So that we can control the attributes in the methods. We can change the code without affecting the parts, and it provides security of the data, and we have the better access control to the all the variables and methods of that particular class. And how does the word encapsulation formed? It came from the word capsule. So it combines the variables and methods, as I previously said, and the variables are suggested to be kept private and the methods are suggested to be kept public inside a class to achieve the encapsulation. And when we keep it like variables are private and the methods are public, if any class is accessing this class, they will just know the methods. They won't be getting the what all variables we are using and how we are using them inside it. So in this way we achieve the one more layer to the security. So now let's say we have a class, public class student, in which we have a name, and then we have a get name and a set name method. So here we are keeping the variable which is called the data variable or a data member as a private, and the method get name or set name we are keeping them as public. So if somebody is accessing the methods, they will just know the methods there. What is the advantage of the encapsulation? We can make the class read only or write only by using the encapsulation, as we can keep the access modifiers that public and private. It provides us the control of the data. It is a way to achieve data hiding in the Java, because the other class will not be able to access data through the private data members, as we saw in the previous example. The encapsulation class is easy to test. Also, when we are doing the unit test cases, it provides us the accessibility of using the private methods over there. So now comes the third pillar of the OOPS, which is called inheritance. Inheritance is just in layman form like something we are inheriting from a parent to a child. So in the same way, we will say inheritance is a mechanism in which one class is allowed to inherit some features from another class, from the parent class to the subclass. In Java, inheritance means creating new classes based on the existing ones. A class that gets inherits from another class can reuse the methods and fields of that class, and also in addition they can add their own methods into their particular that class. In Java, whenever we are inheriting something, we use extends keyword. Why we need inheritance? For method overwriting and for the code reusability. Method overwriting is only possible through the inheritance, and the subclass contains all the methods from the superclass. So we should always create the object of the subclass, which is the child class, because it already inherits the members from methods from the parent class. So there are four type of inheritance majorly in Java, which is single level inheritance, multi-level inheritance, hierarchical inheritance, and multiple inheritance. So now the single level inheritance we will talk about. This in the single level inheritance, the parent class will provide some features to the child class. So here the class A is the parent class and class B is the child class. So class B, which is the child class, inheriting some functions, some methods from the parent class, which is class A. How we are getting those things inherited is, we have a class A which has some functions, and then we have a class B which has has some functions from class A, as we are using class B extends keyword A. So it is extending class A into the class B. So it has methods from the class A and its own functions of the class B. So now the multi-level inheritance. In the multi-level inheritance, one is the parent class, and then we have multiple sub-child classes. So class A, class B, class C, class D. Class A is the parent class. All B, C, D classes are subclasses. For every subclass, the one level up is the parent class to that subclass. Here, class B will have access to class A and have its own functions in the class B. So the class A will have class A and class B functions with it, and class D will have all the functions of all those classes. So now we will talk about the hierarchical inheritance. In hierarchical inheritance, class one, there is one parent class and there could be multiple subclasses in the same level. So here class A is the parent class, and then class B to class C, all those would be the subclasses over here, which would be connected to a single parent class, which is called class A here. Yeah. And then we have multiple inheritance, in which we have multiple parents for a single subclass, and this is not supported directly in the Java, though it is supported by interfaces, but it has people generally try to not to use it because it provides the ambiguity, the confusion of like which parent class methods we have and which we don't have. So to not to have that ambiguous code, we just try not to use the multiple inheritance to us. So now let's talk about the advantages of the inheritance. First thing, it provides us the code reusability because the subchild has access to all the methods of the parent class, and we don't have to write the same code again and again. So thus it reduces the duplication of the code. Abstraction, because it allows us the creation of the abstract classes that defines the common interface for the group of related classes. And then it provides us the hierarchy, in which can be used in the real world entities for the different relationships. And then after that, in the polymorphism also, inheritance allows the polymorphism, which is the ability to talk and like take the object into the multiple forms. But also there are disadvantages of inheritance. So because let's say we have a quite big code, it can comes up to the complexity, because when there is a huge level of code, it is difficult because to understand every part, and to if even if a single change is there, we have to test the entire code, because the existing code should not break. And the same thing is for the tight coupling, because everything is used here and there couple of times. So the subclass it makes us difficult to change the superclass without affecting the subclasses. So we have to write many different test cases to ensure no previous code is harmed when we are changing into the new code. So now let's talk about the fourth pillar of the OOPS, which is called polymorphism. So polymorphism is a Greek word which comes from the two different words. One is the poly, second is the morphism. Poly means many and morphism means forms. So polymorphism in short means the many forms. So the polymorphism means having same objects which has different behavior. So let's take example. Like for example, I am the person. I can be a school, a teacher. I can take a course somewhere else. So there I could be a student. I can be a principal of the particular school, or I can be a vice principal for any school. So I am the same person, but I can have a different role. So that is I am the object and I can have the different behaviors to me. So here you can see the method name is same, the void person, but inside the parameters I am changing what kind of behaviors I am providing or passing every time we have a different role. So be it a teacher, student, principal or vice principal, we have to pass that particular kind of behavior or into the parameters to tell what kind of person is coming over. So that is achieved through the polymorphism. So polymorphism comes in two types. One is compile time, one is runtime. Compile time is also called as early binding or the static polymorphism, and the runtime is called dynamic polymorphism or the late binding polymorphism. In the compile time, we can say how we can achieve is we can achieve it by method overloading. For example, we have a calculator function over here in which we can do addition by using uh, different methods. So here in the first method we are doing two integer additions, the two different integer additions, and in the second method in which the method name is same but the return type is different, which is double. So also I am receiving the data in the double. So let's say I have a different kind of data which will be a double. So here I am just adding those and I am returning that double in the return. So the method name is same but the data type which has to be returned is different. That is called method overloading, and which is like the compile time polymorphism. And then there comes the runtime polymorphism, which is called the late binding polymorphism as well. It is achieved through the method overloading. So how is, like, let's say we have an example which has a method get rate of interest, right? Whatever rate of interest is there, we have to get that. So but there are different banks and different banks can have different kind of rate of interest. So let's say we have HDFC, Kotak and PNB, all three have 1, 2 and 3 rate of interest. So every method has their API exposed or something exposed as a function where we can get their particular rate of interest in the return. So that is achieved through the method overloading. So let's say in the example we have now class bank where I have a basic function class get rate of interest where I'm returning the base 0, and then I have a class HDFC which is extending now the bank class, and here I'm returning my rate of interest is 8.4. In the same way, class Kotak is extending my base class bank, and it is returning the different rate of interest in the float which is 7.3. And likewise PNB is also extending the base class which is bank, and class PNB extends bank, and also it is returning the float rate of interest which is here 9.7. So I think this covers our entire OOPS, how it works, how exactly these four pillars works, and what exactly these four pillars are. So if you liked this video, if you understood anything from this video, I would request you to like this channel, subscribe to this channel, and comment some your feedback into this video. If there is something scope for the improvement, let me know. I will try to look forward to that to improve. Thank you so much for watching.